Let's look at lesson 2 today. We're talking about circles. A circle is the set of all points in a plane whose distance from a fixed point in the plane is constant. In other words, when you have the center of the circle, here we have our center, all the points that have the same constant distance from that center form the circle, where HK is the center of our circle and XY is any point on the circle, and the distance from the center to a point on the circle, that's called our radius. So the center is the point that's the same distance from every point on the circle, and the distance between the center and any point on the circumference is called the radius. Our standard form equation, when the center of the circle is at the origin, is displayed here. X squared plus y squared is radius squared. But when you move off of the origin, then we need to use transformations with x minus h quantity squared and y minus k quantity squared to move that circle off of the origin. So let's jump right into our lesson. We want to write the equation of a circle with the given characteristics. And in this first one, the center is at the origin and the radius is 7. So our model is x squared plus y squared equals r squared. And our r is 7, so our equation is x squared plus y squared equals 7 squared, and that's going to give us 49. In example 1b, the center of the circle is at 5, negative 2, and the radius is 8. So we want to use the transformed equation, x minus h quantity squared plus y minus k quantity squared is equal to r squared. And using the information we have, x minus 5 quantity squared plus y minus negative 2 quantity squared equals 8 squared, which gives us 64. So those are fairly easy. For example 2, we're going to write the translation for each one and draw the image. So x squared plus y squared equals 1 is a circle who's centered at the origin and the radius is 1. And we want to write a transformation that moves the circle 4 units left and 3 units down. So to translate 4 units left, that's x minus negative 4 squared, and 3 units down, that's y minus negative 3 to move it down, and then 1 squared is 1. So we have the same size circle, but we've moved that 4 units left and 3 units down to put the center right there. Same circle, just in a different location, down here in quadrant 4. For 1b, we've got x squared plus y squared equals 9, so that's a circle centered at the origin, radius 3, so it's a little bit bigger. We want to move the circle 2 units to the right and 3 units up, so that's going to put the center of our circle at 2, 3. So 2, 3. This is the center. The radius is 3. So it's the same circle, just translated 2 units to the right, 3 units up. And that equation would look like x minus 2 quantity squared plus y minus 3 quantity squared equals 9. So we've moved that circle. Example 4 wants us to find the radius of the circle and write the equation in standard form. And we have the distance formula. So if we want the radius, we can find the radius using the h and k values with x minus h instead of using x sub 2 and x sub 1, y sub 2 and y sub 1. We can use x minus our h value and then y minus our k value to find the distance on the circumference of the circle. So that's our approach here. And then taking the square root, so we'd have from the center to our xy point. And here you can see that our center HK is located at -2, 0, and our xy point here is located at -1 and +2. So we can use xy is located at -1, +2. So the radius is going to be our x value, which is -1 minus our h value of -2 squared, plus our y value, which is 2, minus our k value of 0, quantity squared, which gives us a radius of 1 squared, which is 1, and 2 squared, which is 4. So the radius of our circle is radical 5. And then writing the equation for that circle, using our information, we have x minus -2, that's our h value and our k value. So x plus 2 quantity squared, and y minus 0 quantity squared is y squared, and r squared would just be 5. So the square root of 5 squared gives us 5. And that's example 3. So on to example 4. They want us to find the equation of the circle whose endpoints of the diameter are located at 5, 3, and -1, -5. And in our picture, we don't have any numbers on our scale to keep the picture neat. But what we're wanting to do is we're wanting to find out where the center of the circle is. And one way we can accomplish that is to count the rise, which is 1, 2, 3, 4, 5, 6, 7, 8, and the run, which is 1, 2, 3, 4, 5, 6. So we have a rate of change, 8 units up and 6 units right. So that change in y over the change in x gives us the slope, which is 4/3, which means if we go back to our point on the diameter and rise 4, run 3, that puts us right there in the center at 2, -1. And then that would, again, rise 4, run 3, take us to the other point on the other side of the circle. So we have the center at 2, -1, and the radius is going to be, well, let's figure that out. The radius is 5 minus 2 quantity squared, not cubed, quantity squared, plus 3 minus -1 quantity squared. So 3 squared is 9, and 4 squared is 16. That's the square root of 25. So our radius is 5. That makes the diameter 10. Not that we needed that. And we know that our HK is 2, -1. So the radius was 5. Then our equation is x minus 2 quantity squared plus y plus 1 quantity squared equals 5 squared, so 25. So that's fairly simple. Example 5, you want to find the standard form of the equation for the circle by completing the square. So similar to our parabola, we want to set up x squared minus 6x, and then take half of 6, that's 3. 3 squared is 9. And then group the y squared terms, so y squared plus 2y, and complete the square again. Half of 2 is 1. 1 squared is 1. And then on the right-hand side of the equation with the 6, I have to add 9 and 1 to both left and right side to keep that equation balanced. Factoring the first trinomial is x minus 3 quantity squared, And then the y terms factored are y plus 1 quantity squared. And 9 plus 1 plus 6 gives us 16. So we know the center is located at 3, -1, and we know that the radius is 4. So I would recommend that you turn the video off and try part B on your own, then come back to check your work against mine. If you worked everything out correctly, you noticed that you needed to regroup the 6x with the x terms and the -4y with the y terms. You took half of 6, that's 3. 3 squared is 9. Then half of 4, that's 2, and 2 squared is 4. So you added 9 and 4 to both sides of your equation. Your equation for your circle looks like this, with the center at -3, 2, and the radius at the square root of 28, which simplifies to 2 square roots of 7. So we just have two more equations, two more examples. In this case, we want to write the equation for the circle whose area is 25 pi, and the center is located at 3, -2. Before we can get the radius, we need to figure out that the area of a circle is pi r squared, and if our area is 25 pi, and that's equal to pi r squared, then the pi's cancel, and the r squared is 25. So this becomes pretty simple. Our h is 3, so x minus h squared, and y minus k, our y is -2, so y plus 2 squared, and it's equal to r squared, which was 25. So this is the equation for our circle. Then our last lesson, our last example, if you have a tanker truck that's overturned on a highway and it's spilling hazardous material, everyone within a 1.5 mile radius of the spill has to evacuate. And the map that safety workers are using shows the spill site at coordinates 4.5, 5. So each unit of measurement is 1 mile. We want to write an equation that describes the boundary of the evacuation region and figure out how many square miles need to be evacuated. So this is a two-part question, and without having a grid with the graph, let's say this is the x and y, that's on the outer boundary, and we have the center here, and the center is at 4.5, 5. So this is our h and our k, and we've got to have a circle whose radius goes along there, and they've told us that radius is 1.5 miles to the edge. So we're trying to write the equation of that circle. So we know that the center is at 4.5, 5, and we know that the radius is 1.5 miles. So the second thing we want to do is write the equation, and then we'll figure out the area of the circle. So the equation is x minus 4.5 quantity squared, and y minus 5 quantity squared, and 1.5 squared is 2.25. So this is the equation for our circle. And then the total area that needs to be evacuated. We know that the area for a circle is pi r squared. And the area for this particular circle is going to be the radius squared, which is 2.25, times pi, and using your calculator, that's roughly 7 7/700 square miles of area that need to be evacuated to get away from that hazardous material spill. And that, my friends, is the end of day 1, lesson 2 on circles. See you next time for ellipses.